22, generate parentheses given n pairs of parentheses. Write a function to generate all combinations of well-formed parentheses. So the number like 3 is given here to us, and we should generate n pairs of we should generate all the combination of well-formed parentheses. What is a well-formed parenthesis? A well-formed parenthesis is something that when we have an open bracket, we are open parenthesis, we are going to have a closed parenthesis as well. So this is going to be a well form. So what you see here, we are going to have 3 open and 3 closed. We are going to have 2 open, 1 closed, open, close, close, and these are the combination that you can see. So when we are talking about permutation combination, recursive functions are going to be very helpful. And what we can do, we can use backtracking. So this way we can keep track of the changes, and we can undo changes after, undo choices after. So let's see how we can do that. Let's write down the plan of attack. The plan of attack is going to be what I'm going to do, I'm going to have a backtracking function. And in the backtracking function, I'm going to have a like base case. The base case is going to be if the length of the formed parentheses, let's put the formed parentheses into a string. If length of the string is equal to the length of the n multiplied 2, why n multiplied 2? Because we are going to have 3 pairs of parentheses, right? And a pair of parentheses is an open bracket and close bracket. So if the length of this string that I have, that I'm making, if it is equal to n multiplied 2, then I'm going to add it to the final list, to the result list. And what is the recursive case? The recursive case is what we are going to do, we are going to use 2 pointers, a left pointer and a right pointer. A left pointer for the open parentheses and a right pointer for the closed parentheses. And what we are going to do, we check if the number of left is small, like if the number of left parentheses, which is open parentheses, that we have is smaller than n, which is 3, then we are going to call the function, backtrack function again. But and then we check if the number of right parentheses, which is going to be the closed parentheses, is smaller than left, which means we don't have like enough left for all the enough closing for all the opening. We are going to call the backtracking function again. So let's see how we can do that. Let me close this. Okay. To do that, what we are going to do, I said we are going to have a list that we are going to put all these combinations in it. So I'm going to say combinations is equal to the list. This is the final list that we are going to return as a result. And then I'm going to have a backtrack function that what I'm going to give every single time that I call the backtrack function, I'm going to have an empty string that I'm going to add the parentheses to it, and then I'm going to have a left and I'm going to have a right. I'm going to have a left and I'm going to have a right pointer. And what I'm going to do, I'm going to say if the length of the string that I have is equal to the 2 multiply n, then what I'm going to do, I'm going to say combinations dot append the string, and then I'm going to return. And otherwise I check if the left that I have is smaller than n, I'm going to call the backtrack function again, backtrack with the same string that I have, a string plus, I'm going to add an open parenthesis, right? I'm going to add an open parenthesis. I'm going to add 1 to the left, and I'm going to leave the right here. And then I check if the right that I have is smaller than left, so it means the number of closed bracket are smaller than the number of open bracket, I'm going to call the backtrack function again. And this time I'm going to add close parenthesis instead, right? And I'm going to leave the left as it is, and I'm going to say I have add one close parenthesis here, right? There we go. And finally, what I'm going to do, I'm going to call the backtrack, but we are going to have an empty list. We are going to have, we're going to have an empty list. We start from 0 and 0, which means we have no open or close parentheses. And finally, I'm going to return the combinations as a result. So this is the way that we are going to solve this problem. For better understanding, I have illustrated this thing that is happening here. So this is the example for the n equal to 3. So we call the backtracking function for the when left is 0 and right is 0. We are going to check if the length is equal to the 2 multiply n, then we are going to add. Otherwise, we are going to call the backtrack function and add an opening and add 1 to the left, and then we are going to call the right, like we are going to backtrack function for adding a closing bracket, and we are going to add 1 to the right. And this is the combination, and same as the code that we saw there. So what is happening here, we call the backtracking function for 0 and 0, right? We add 1 parenthesis, we check it's not equal to 2 multiply n, and the left is 1 and is smaller than 3. So we call the backtracking function and we add another open parenthesis. And we check 2 is smaller than 3, so we call the backtrack function and add another parenthesis, so it's 3. Now 3 is not smaller than 3, so now we are going to the second if. So 0 is smaller than 3, so we are going to add 1 here, close parenthesis, another close parenthesis, another close parenthesis. And here is when we meet this condition, to length of the string that we have here is equal to multiply n. So then we are going to add this to the combination, and then it backtrack, it goes here and here and here and goes here, and then it does this and it adds this combination and it adds this combination and this and this, and finally it's going to return the result. As you see, the time complexity is going to be 4 power n over n squared, and the space complexity is going to be the same. Thank you.